we will be seeing the second experiment in volumetric analysis, that is oxalic acid versus KMnO4. You saw more salt with KMnO4, now we will be seeing oxalic acid versus KMnO4. Here you are supposed to prepare 1 by 20 molar of oxalic acid solution and titrate it versus KMnO4. Here also you have to find the strength and molarity, but we have an extra question over here. You also have to find the percentage purity of the KMnO4 sample. That is, you will do the titration and find the molarity and strength of the KMnO4 solution. After finding it, you will arrive at some grams per liter, right? Strength is how many grams per liter. So after arriving that, we have given you the actual value, how much we have dissolved. So from that you will find out how much purity is there in the sample. So we'll just say how to go about it, but the rest all procedures are same. The same question can be asked even in more salt solution. I am just giving you one example of purity with the oxalic acid. Same can be asked even with more salt solution. Okay, let us see what is the aim of our experiment. To prepare 100 ml of 1 by 20 molar oxalic acid solution, and with its help to determine the molarity and strength of the given KMnO4 solution. That is your first aim. You will find the molarity and the strength, and then as I told you, you have another aim also, to find the percentage purity of the impure sample of KMnO4, which will contain, how much it contains? 3.5 grams, of which has been dissolved in 1 liter of the solution. So I am telling you I have dissolved 3.5 grams. You have to find out exactly how much I have dissolved, and from that find out the percentage purity. Okay, the rest of the procedure remains the same. Let us see what is the theory behind, or as I told you, it is a redox reaction where the permanganate ion gets reduced to Mn2 plus from +7 oxidation state, and the oxalic acid, the oxalate ion, gets subsidized to carbon dioxide and water. So it is again in the acid medium. We will be adding 1 test tube of dilute sulfuric acid. Here you don't have to add dilute sulfuric acid while you are preparing in the standard flask, but you have to add 1 test tube after pipetting out into the conical flask to make your medium acidic. Okay, so the reaction is MnO4 minus, that is a permanganate ion in the acid medium, H plus, give with the oxalate ion, gives you Mn2 plus carbon dioxide plus water. I have given you the balanced equation, 2 MnO4 minus plus 16H plus 5 oxalate ions, giving you 2 Mn2 plus 10 carbon dioxide plus 8 water molecules. Okay, so now the next thing is to prepare your standard solution. For that you have to know, to prepare 1 by 20 molar, how much of oxalic acid you have to take, right? So oxalic acid is a dihydrate solution, means acid. Dihydrate means with 2 water molecules of crystallization. So your molar mass will be including that. So you can see here the formula of the oxalic acid is COOH dot 2H2O, means 2 water molecules of crystallization, which the molar mass comes up to 126. So we know that you have to write this. No saying that you know it. You have to write this. 1 liter of 1 molar solution of oxalic acid contains molar mass of the substance, that is 126 grams, and therefore 100 ml, your standard flask volume is 100 ml. So 100 ml of 1 by 20 molar solution of oxalic acid will contain how much? So you do the calculation, 126. Okay, so 126 divided by 1000, that is for 1 liter it is. So multiplied by 1 by 20 molar we have to prepare, multiplied by 100 because you have to prepare for in a 100 ml standard flask. Only 100 ml you have to prepare, which comes up to what? 0.63 grams. So 0.63 grams is the weight of oxalic acid that you have to take in your balance. You have to weigh it first and come. Then wash your standard flask clean, and then you have to proceed to make up the solution. Okay, this is how you will present in your board. That's what we are saying. The procedure, you don't have to write the lengthy procedure again. You just have to say what all. We just want to know whether you are knowing what is to be taken in the burette, pipette, etc. So just write that. So burette solution, you will be taking the permanganate solution. Pipette solution will be your oxalic acid, which you have made in the standard flask. From that you will pipette out 10 ml into the clean conical flask, and do not forget to add what? Dilute sulfuric acid, that is your medium, so which is acidic. Indicator will be the KMnO4. It is a self indicator because you know the color changes from, because of the change in oxidation state, there is a color change as well. and the end point is colorless to permanent pale pink color. It has to be permanent pale pink color. You wait for just 1 or 2 minutes to see if it doesn't fade away. Okay, and your medium is acidic, as I told you, and temperature. Here, this is very important. Temperature, you know that we have to heat oxalic acid and bring it to bearable warmth. That is how long you have to heat. When you see some water droplets after pipetting out into the clean conical flask and adding 1 ml, one test tube of dilute sulfuric acid, that is 10 ml, you will keep it for heating. And then by the time you can fill up your burette to manage your time and see that the nozzle portion of the burette, everything is filled up, and then you remove the funnel from the burette top, and then you start doing that is after having heated. You can see some water droplets on the sides of the conical flask. Then just remove it. Why are we heating, by the way? Oxalic acid being an organic compound, the reactions are very, very slow. So in order to make the reaction fast and some carbon dioxide is evolved, that is also to dissolve that also, we are just heating it. Okay, so this heating is required to bearable warmth, so the reaction is little faster. And so 60 to 70 degrees centigrade, you don't have to use a thermometer to measure whether the temperature is 60 or 70, just bearable warmth where you see the water droplets on the sides of the test tube, conical flask. Okay, molar mass of KMnO4 is 158 grams, as we know, that is required, so you will mention that. And then you, after writing this, you draw the observation table. This has to be ready. First you have to do everything all these things in the paper, and then only you start performing the experiment. Once your experiment is over, fill in the values and get it attested from the teacher. What are all the things that should be in the tabular column or in the observation table? You have to write what is the titration, standard oxalic acid versus KMnO4. Standard oxalic acid means the oxalic acid molarity, you know, I told you, that is standard oxalic acid means whose molarity is known. A standard solution is the one whose molarity is known to us. So it is standard oxalic acid 1/20 molar versus KMnO4. So volume of oxalic acid, and then that will be how much? 10 ml, right? We are going to pipette out 10 ml. So 10 ml, all the time we will be pipetting out 10 ml only. So it will be 10 ml all the time. Burette reading, you have to write initial and then final. I told you 0 will be the initial burette reading always. Even if you have finished once doing the experiment, refill the burette to 0 and then only do. And again, as I told you, it is a colored solution, so the upper meniscus to be seen in the burette. And for standard flask, where you are making up the solution, lower meniscus to be seen, because both more salt and oxalic acid are colorless solutions. Lower meniscus to be seen. Okay. So final reading, as and when you do your experiment, you will get the values. Let me take a hypothetical value of 10, as if I got a 10 reading all the 3 times. It can be different, but 2 successive readings should be the same. Till then you are supposed to perform the experiment. Volume of KMnO4 will be final minus initial, which will be again 10. Your concordant value will be the one which has been repeated successively. So it will be 10 ml. Okay, your concordant value is 10 ml. After you have done this, you come and get it attested from the examiner. Once the examiner gives you the permission, any teacher, whoever is here, you have to get it attested or get it signed. And once you get this, then only you can perform or go ahead with your calculations. Okay, we'll see the calculations next. I'll just demonstrate you the preparation of more salt solution. Titration of more salt solution with KMnO4 to find the molarity and strength of KMnO4 solution using the more salt solution. You are supposed to prepare 1/10 molar more salt solution, right? So we know, we have calculated how much you should take. 3.92 grams of more salt you have to take. So let us see. First you use the balance. Okay, so you see whether the balance is in 0 position. Take the weight of paper. Whatever the weight of paper is shown, you tear it. You say here there is a button called tear. Tear the weight of paper, and then you add the more salt that you have to take little by little from the container. Okay, and see that your reading is up to the, just check whether your reading is coming up to 3.92. Okay, so your 3.92 grams of more salt should be weighed and taken. Okay, now once you have taken, so you have now taken the weight of more salt. Now what should I do? I should prepare the more salt solution in the standard flask. Okay, I should prepare the solution in the standard flask. Before that, I have to wash my apparatus. All the apparatus to be washed before you use. Okay, so wash it. Then to prevent the hydrolysis of more salt, just add, why we are saying, because in the beginning only you add so that you don't forget. To prevent the hydrolysis of more salt, you just add dilute sulfuric acid. Okay, just add dilute sulfuric acid. You can just add some amount, approximately 5 to 7 ml, and then transfer the contents of the more salt. Okay, transfer the contents of the more salt. Keep the standard flask, put the funnel. Okay, put the funnel, transfer the contents, that is this more salt solution, into this funnel. Okay, see carefully you transfer. Okay, after having transferred, now wash your funnel with the wash bottle, that is water from the wash bottle. Just lift the funnel, see that the entire content in the funnel is being transferred, and also just lift the funnel, wash the stem of the funnel. Okay, wash the stem of the funnel, keep it aside, and lift the funnel. Keep it straight to your eyes. There is a mark here in the standard flask. Can you see that? There is a mark in the standard flask. There is a mark over here. Till that mark, it is 100 ml. Till this mark, it is 100 ml. Okay. So you just see, you can keep on filling water till that mark. You have to exactly add water till that mark only. You can add, in the beginning you can add more water, but as you are nearing the mark, be very careful to add the last drops, either using a pipette or, okay, just make it up to the mark now. You can still add some more water. Last drops you can use the pipette. Okay, so last drops can be added using a pipette, so that my mark is exact. I think I can add one more drop to make that. Since it's volumetric, we are very much concerned the solution should not become more dilute. So we are very much concerned with the mark, with the, means to up to what we are making. No extra water should be added. Right? Yeah, I think I have made it exactly 100. Can you see that line coinciding? Okay, so now stopper the bottle. You seen that I have added dilute sulfuric acid. I have added the contents. To prevent hydrolysis, I added sulfuric acid, and I then added water, and then now made up to this ml. Okay, 100 ml. Now stopper it, tilt the contents of the flask, and ensure that the salt has completely dissolved in it, and just see that it is being completely dissolved and the solution is uniform concentration. Solution is of uniform concentration. Now our standard solution is ready. Okay, standard solution is ready. Now next I have to get ready with my burette, right? So I will just remove the burette, wash my burette with water. Okay, wash my burette with water. Okay, wash my burette with water. And then rinse the burette with the respective solution. What is the solution I have to take in the burette? I have to take KMnO4. So I will add a little of KMnO4. Okay, I am adding a little of KMnO4 and I am just draining out the solution. I am just draining out the solution. Okay. The rinsed solution should be thrown away. It is just used to make, as I told you, this is just to wet the burette so that any water droplets in the burette does not dilute the solution further. Okay, that's the reason. Now we will fill it up to the 0 mark. Use the funnel for filling it up. Okay, use the funnel. When you fill up the burette, care should be taken that the nozzle portion of the burette is also filled. Your burette is graduated to 25 ml with the nozzle portion only. So if any air bubbles are there, you just drain out from the bottom and see that the nozzle portion is filled. Okay. So now keep your beaker here and see, it is not filled now. Okay. I am taking care to fill up that. How? By taking it above the 0 mark. I just open and you know now the nozzle portion is filled, and then I now check for the 0 reading in the burette. It is slightly less, I believe, right? So let me add some more and now make it up to the 0 mark. Now let me make it to the 0 mark. Okay. So now I have to check for the upper meniscus because it is a colored solution, right? It is a colored solution. So I will check for my upper meniscus. Now I will keep it up, set it up or put it up in the stand. Now my burette solution is ready. Then I have to get ready with my pipette. Now pipette, I should wash the pipette with water. So just tilt it and then throw away the water contents and then rinse your pipette with the respective solution. Now always mix the solution and take it out, then remove it, and I am rinsing my pipette now. Okay, I am rinsing. Just tilt the pipette. See that the solution is fully wet with the pipette is fully wet with the more salt solution that you have made. Throw it out, the rinsed one, and then pipette out. Okay, then pipette out. You have to know here also, you know where is the mark. You have to identify the mark. I don't know, I have exactly taken till the mark. Okay, so I'll just now close it with the finger and put it in a clean washed conical flask. Here you don't have to rinse the conical flask. Okay, just transfer the contents into the conical flask. Now allow it to drain into the conical flask. You don't have to blow the pipette to drain out the last drop. Leaving that last drop only, it is graduated for 10 ml. Okay. Now just touch the bottom of the conical flask 2 or 3 times and then you can remove your pipette, keep it aside. Now we are having more salt solution. Pipetted out 10 ml. What am I supposed to do now? Add 1 test tube of dilute sulfuric acid to make the medium acidic. Okay. So now I will add 10 ml, which is approximately 1 test tube. So you will add dilute sulfuric acid, okay, which you will take 1 test tube and you will add I am transferring it into the conical flask. Now the medium is acidic. You have studied in your D block elements, KMnO4 is a good oxidizing agent in the acid medium. Okay, so I made the medium acidic by adding 1 test tube of dilute sulfuric acid. Okay, now I have to start the titration. Your both hands should be engaged. Open the nozzle of the burette from the back side, and or you put your whichever left hander or right hander accordingly, whichever you feel convenient. You open the nozzle of the burette and then go ahead with the adding drop by drop. Okay, just continuous shaking, and the drop should exactly fall inside the solution, not on the sides of the conical flask. You should be able to control the content from the conical flask, from the burette. Okay, so you keep on adding, okay, and see that it is entirely falling into the conical flask in the solution only. Yes, drop by drop. When you get the pale pink color, you just stop. Okay, just remove the conical flask if you are not able to stop the reading. Then okay, so this you can see, this is the pale. It can be even paler than this if you can. Okay, this pale pink color that you can get. Okay, so once you have finished this, now you note your reading. How do you note the reading? Okay, so you can use this paper that is from the white background so that you avoid the parallax error. Okay, just see that. Just see, you can keep it, you can hide it. Okay, and where your reading is there, you can close it and you can avoid the parallax error. See the upper meniscus for colored solutions. See the upper meniscus for the colored solutions where you can hide it from here. Okay, using this paper, parallax error is avoided. So you can just take the reading. Okay, now my reading is coming up to 10. Okay, it is between 9.9 and 10. It's between 9.9 and 10. Okay, fine. Now my experimental part is over. Now the same procedure I will repeat till I get a concordant reading. So I'll throw it off. I'll wash my conical flask, pipette out again 10 ml into the clean conical flask, wash it, then pipette out, add 10 ml, 1 test tube of dilute sulfuric acid, repeat the same experiment. So when I'll repeat, the experiment is repeated thrice, and out of which 2 consecutive readings should be the same value. Those 2 readings which are of the same value are called the concordant values. Okay, so this you have to do. See for the color, don't forget to add dilute sulfuric acid. So this experimental part is very important. After having noted the values, you know the value, enter it in your paper, get it attested from the examiner. So now I am just going to demonstrate you the preparation of oxalic acid, standard oxalic acid, and the titration versus the KMnO4 oxalic acid, standard. So you just take the weight of oxalic acid, use a paper, just put it on the balance, find out what is the weight of the paper, tear it out, and tear it means make it zero now with the paper, and then just take, how much have you to take? You have to take 0.63 grams of oxalic acid. That calculation you might have done in your paper, right? So just add 0.63. Just you can see the balance reading. Accordingly, remove or add what is required. Okay? So accordingly you do. Just take 0.63 grams. So transfer the contents just into the washed standard flask as I demonstrated for you. Into the washed standard flask. And now wash your more salt. See that here you don't have to add dilute sulfuric acid. In more salt we added because to prevent hydrolysis. Here it is not necessary. In more salt we added to prevent hydrolysis. Here it is not necessary. See that. Okay, you can just add water and wash the stem of the funnel as well. Okay, and you make it up to the 0 mark over here. Okay?
And you
so
make it
0 mark, you add 0
keep
mark,
on
adding
over
water
here.
and
Okay?
fill it up to
So
the 0
mark,
level over
you
here.
you
I
keep on
just
adding
prepared
water and
this
fill it up to the 0
oxalic
level
acid.
over here.
Okay, I just prepared the oxalic acid because we have to keep it for heating. This oxalic acid is
because we have to keep
organic
it for
compound,
heating. This
which
oxalic
reaction
acid
is very slow, so we cannot have the
organic
reaction in
compound,
room
which,
temperature.
reaction
So
is
what we
very
have to do
slow.
is
So
we
we
have to
have
put
the
out
reaction in
the
room
oxalic
temperature.
acid
So what we
into
have to do
this,
is we have to put
add
out the oxalic acid into this, add
just see the lower meniscus for colorless solutions. Pip it out into the clean
the
conical
lower
flask.
meniscus for colorless solutions.
Okay,
Pip it out into the
Same
clean
way.
conical flask.
just
Okay, same way.
allow the solution to drain into the conical flask. Don't have to blow
Allow
the
the
last
solution
drop.
to drain into the
Just
conical
touch
flask.
the bottom
Don't
of
have to blow the last
conical
drop.
flask 2 or 3
Just
times
touch the
and
bottom
keep it
of
aside.
the conical flask
Now
2 or 3
don't
times.
forget to add
and
1
keep it aside.
1 test tube of
Now
dilute
don't
sulfuric
forget to
acid
add one
to make the medium
one test tube
acidic.
of
Okay, so add dilute sulfuric acid.
to make the medium acidic. Okay, so add dilute sulfuric acid.
Okay. Add the dilute sulfuric acid to this.
Add the dilute sulfuric acid to this.
And then now because the reaction is very slow, keep it for
And
heating.
then now
Okay?
because the
keep
reaction
it
is
for
very slow,
heating.
keep it for
You have to
heating.
keep it for heating.
Keep it for heating.
Just
You
light
have
the
to keep
burner.
it for heating. Just light the burner.
Keep it for heating and see that there are, you don't have to heat it till boiling, just there are some water droplets on the sides of the conical flask.
Boiling.
Okay,
Just
so there are some water droplets on the side, that means 60 to 70 degrees centigrade.
So there are some
Bearable
water
warmth.
droplets on
It
the
should
side.
have
That
some
means
bearable
60 to
warmth.
70 degrees
Not
centigrade.
too hot.
Bearable
No,
warmth.
only to catalyze the
bearable
reaction,
warmth.
just to
Not
make the
too
reaction
hot.
occur faster. You all
Only
know
to
that the
catalyze
reaction
the
occurs
reaction.
faster
Just
at higher
make the
temperature,
reaction
and
occur
also
faster.
some
You all
carbon
know
dioxide
that the
will
reaction
be
occurs
evolved,
faster at
so
a
they
higher
dissolve that
temperature.
also.
And also
Okay,
some carbon
so
dioxide
just
will
heat
be
it
evolved
to bearable
dissolve
warmth.
that also. Okay, so just heat it to bearable warmth.
You can see some water droplets that are settling on the sides of the conical flask.
You can see
Okay.
some water droplets that
So-
are settling on the sides of the conical flask.
It should be hot enough when you touch from the bottom of the conical flask.
It should
That's
be hot enough
small
when you touch from the
vapors.
bottom of the
Slightly the vapors will start coming out,
small
and then
slightly the vapors will start coming out.
here
And
again the
then-
end point is appearance of permanent pale pink color. By the time
Here
if
again the
I
end
have
point
already
is
filled my
appearance of
burette,
permanent pale
in
pink
case
color.
you
By
have
the
not
time
done, by the time
I
it
have
gets
already
heated, you
filled
can
my
go
burette.
ahead with the
In
filling
case
up of the
you have
burette.
not done,
See that
by the
always
time
the
it
nozzle
gets
portion
heated,
of
you
the
can go
burette is
ahead with the
filled.
filling
Okay.
up of the burette.
Now I
See
think
that always the
yeah.
nozzle portion
Can you
of the
see
burette
this?
is filled.
Can you see the water
Now I
droplets on the
Yeah.
sides
Can you
of
see
the
this?
conical flask?
Can you see
I
the
can
water
touch the bottom.
droplets
It is
on
not
the
very
sides
hot,
of the
nor
conical
it is
flask?
cold.
I can
it is
touch the
bearable
bottom.
warmth
It is
that I am
not
having.
very hot,
If you find
nor
it
it is
hot,
cold.
you can use your
Bearable
handkerchief
warmth that I am having.
or your rough
If you
cloth
find it
to
hot,
hold that.
you can use
okay?
your handkerchief
and then put off the
or
burner.
your rough cloth
Be
to
careful when
hold
you do
that.
the experiments.
And
just
then
now
put off the
start
burner.
titrating
Be careful
in
when
the
you do the
same hot
experiments.
condition.
Just
Can you see
now
some water
start
droplets?
titrating
You have
in the
confusion
same
at what
hot
time
condition.
to- So
Can you
just
see some water
there should be
droplets?
some water droplets of
You
fumes
have
coming out,
confusion at what time
and
to-
the
just
solution
there
should
should
be
be some water
having
droplets
variable
coming out.
warmth. Now start
And
adding
the solution should
the
be
drop one by one.
having variable warmth. Now start adding
Slowly, drop by
the
drop.
drop one by one.
The drop should add exactly
Slowly,
into the
drop by
conical
drop.
flask.
The drop
Not on
should
the
add
sides.
exactly into the conical flask, not on the sides.
Even if it happens, try to take the drop into that so that
Even if it
KMN4
happens,
is
try
being
to
used
take
up.
the drop into that so that KMN4 is being used up. drop it, drop. Add, drop it, drop. You will repeat the titration for concordant readings. Okay? You will repeat the titration for concordant readings. Hot condition, don't talk with your friends. So here you have to be very careful. Just concentrate on the work that you are doing. Don't talk with your friends. Just concentrate on the work that you are doing. Then note down the titer values, get it attested from the examiner and do the calculations. Then note down the titer values, get it attested from the examiner and do the calculations. Okay. Can you see that? Slowly the solution is retaining its pink color. Can you see that? Disappearing little later. Slowly the solution is retaining its pink color but disappearing little later. Okay? Yeah. We have arrived at the end point. Yeah. Slightly dark you can see. We have arrived at the end point. You can still stop even a lighter, it is even more good. You can see. Take it at the pink. You can still stop even a lighter, it is even more good. White background, you can see the pink color. Pink color should be applied. White background, you can see the pink color. Note down the readings. Color should be applied. Take the burette in your hand. Now, it is better to take the burette in your hand. Take the burette in your hand. Avoid the parallax. It is better to take the burette in your hand. And just keep it straight to your eyes. Avoid the parallax. Keep the burette straight to your eyes. And just keep it straight to your eyes. Use the paper. Keep the burette straight to your eyes. And then read using the upper use the paper. Okay, use the upper meniscus to read your hand. And then read using the upper meniscus. Now, my reading is again 9.8. Yeah. Now to 9.9. So don't write 9.89 and all. There are no two decimals. 9.8. So don't write 9.89 and all. There are no two decimals. 9.8. Now I will take the lower one. So I repeat this experiment concordant to get a concordant reading. Two successive readings should be concordant. Then I get a concordant reading. Two successive readings should be concordant. Then I note down in the paper and get it attested from the examiner. That's it.
So after having completed the observation table and having got the attestation from the examiner, then you can proceed with the calculation. So how to go about the calculation? First give the formula. What are you supposed to find out? You are supposed to find out the molarity of KMnO4. So molarity of KMnO4 multiplied by volume of KMnO4 divided by molarity of oxalic acid multiplied by volume of oxalic acid equal to 2/5. What does this mean? This is the molar ratio. Where from you got this 2/5? From your balanced equation, from your stoichiometry, where the molar ratios, you are getting the molar ratios in which they are reacting. So you equate them and from that you find out the molarity of KMnO4. You assume molarity of KMnO4 to be X because you do not know, and that is what you are going to find out. Volume of KMnO4, as I wrote in the table, that is hypothetical value. As if I got 10, I have mentioned in the table, so I am writing it as 10 here. If you get 10.1, you write 10.1. If you got 9.9, you write 9.9, whatever value you get, you fill it over here. Then molarity of oxalic acid, what is the pipetting value which you pipetted out 10 ml, so that will be 10 ml, you will write here 10 ml, and that is volume of oxalic acid, and molarity of oxalic acid will be, molarity of oxalic acid will be 1/20 molar, okay, molarity of oxalic acid will be 1/20 molar, okay, and volume of oxalic acid will be 10 ml. Okay, on substitution, that is when you substitute in this formula that you have taken, X into 10 ml, that is X is the molarity of KMnO4, 10 ml volume of KMnO4, which I got as I told you hypothetical value, 1/20 is the molarity of oxalic acid multiplied by 10 ml of oxalic acid, equated to the molar ratio, that is 2/5, calculate for X, 1/50, which comes up to 0.02 molar for me with my hypothetical value. It can be anything for you. Whatever it is, please do not approximate, as I told you. Please do not approximate. 3 to 4 decimals is good because that will minimize your error. Okay. Now strength of KMnO4, what is the formula to find the strength of KMnO4? Molarity multiplied by molar mass. Strength of what are you finding? KMnO4. So molar mass will be 158 for KMnO4. So you'll have molarity into molar mass 0.02 multiplied by 158 equal to 3.16 grams per liter. Okay. Now there was one more question, right? You are asked to calculate the percentage purity of the sample. Now my calculated strength comes up to 3.16. In the question it was given that 3.5 grams of KMnO4 was dissolved, but my calculation says it is only 3.16. This is a pure KMnO4. The rest is impurity. So how will I calculate the percentage purity? Calculated strength divided by the given strength multiplied by 100 because it's percentage purity. So substitute those values. 3.16 which is calculated one divided by 3.5 which is the given value multiplied by 100 which comes up to 90.2 for my value. It can be anything for your value. So and do not forget to write the result. Molarity of KMnO4 equal to 0.02 molar. Strength of KMnO4, calculated strength 3.16 grams per liter, and percentage purity comes up to 90.2%. And then you have to write what? Precautions. At least 2 precautions. What are they? I told you just you have to wash the burette, rinse the burette and the pipette with the respective solutions, and do not forget to add dilute sulfuric acid to the conical flask to make the medium acidic, and also heat the conical flask before you do the titration so that your reaction is faster. All the best.